In this video, we will see how to draw the sinusoidal graph. The graph which represents y is equal to twice sine pi x. Sine and cosine graphs are called sinusoidal graphs because both of them appear with a phase difference. For drawing the graph, we have to compare the given equation with the standard form, that is equal to y is equal to a sine bx plus c plus d. So a is the amplitude, b will help us to understand the period of the graph, c will tell us how much phase shift, and d will tell us how much vertical shift the sinusoidal graph is going to be. So first, let's collect the data. On comparing, we will understand that amplitude of the graph is this one. You're just comparing and taking that. So A is a 2. So height of the graph above the horizontal line, above and below, will be up to 2 units. Period of the graph is calculated as a 2 pi divided by b. And when we compare b is x coefficient, that is pi. So 2 pi divided by pi, which is a 2. So within 0 to 2, one cycle of this graph is going to complete, and rest all will be replication of this graph. Phase shift. Phase shift is calculated using the formula negative c upon b, and since c is not there, d is not there, so there is no phase shift and there is no vertical shift also. So there is no phase shift. Its meaning is sine graphs originate from origin. Now also we are going to get it from origin. So this is the basic information. Now on the horizontal line, that means on x-axis, what numbers or what angles we have to take. So horizontal line, we are going to take the period divided by 4. So period of the graph is a 2. 2 divided by 4, that is 1 upon 2. So here this time we are not taking on x-axis 0, pi by 4, pi by 2 pi, those on. We will be taking numbers, which will be angles, of course. And on y-axis, we always take amplitude. On y-axis, we take amplitude. Amplitude is 2. So on y-axis, maximum up to 2 we are going to take. To draw the graph, first let's get the coordinates. So we have a table here. X we will have to substitute to get y. Y is twice. This is it. So in place of x, we will substitute 0. And you know what, x-axis 1 by 2. I just take a little bit more closer values to get a clear picture of the graph. So on x-axis, we will take 0, 1 upon 4, twice 1/4, means what, half, 3 1/4, 3/4, 4/4, 5/4, 6/4, means what, 3 upon 2, 7/4, 8/4, means what, 2. So 2 is the period. So up to 2, with this one cycle is done. Let me begin with the negative points also. So negative 1/4. Let's take 1 or 2 more. Negative 1 upon 2. Whatever positive points we have taken, put a negative sign, and then, and one more, negative 3 upon 4. Now let's substitute these values in place of x and get the corresponding values of y. When x is 0, sine 0 is 0. So 2 times 0 is 0. When x is 1/4, so sine pi by 4, sine 45 is 1 by root 2, which is 0.71. We are going to multiply 2 to 0.71. So I'm using a calculator to quicken the calculation part here. So sine pi by 4 is sine 45. Sine 45 is 1 by root 2. 1 by root 2 is 0.71. To that we are multiplying 2. So it turns out to be 1.42. Then sine pi by 2. Sine pi by 2 is a 1. Twice 1 is a 2. In place of x, when you substitute 3 pi by 4, means what? 3 times pi by 4. 3 times pi by 4 is going to appear as 45 times 3. 45 times 3, that is 135. So 135 will be in the second quadrant. Second quadrant sign is positive. Positive 1 by root 2 means what? Positive 0.71. So here again we are going to get 0.42. Then sine pi, which is 0. 2 times 0 is 0. 5 pi by 4 means what? 5 times 45. 5 times 45 is 225, which is an angle in the third quadrant. Third quadrant sign is negative. So negative of twice 1 by root 2, twice of 0.71. So negative 1.42. And then 3 pi by 2 means 270. That is sign negative. So here negative 2. 7 pi by 4 means 315. In the fourth quadrant, sign is negative. So negative 1.42. Sine 2 pi, that's 0. Negative 1/4. Negative 1/4. Yeah, here sine of negative theta is negative of sine theta. So negative pi by 4 is negative of sine pi by 4, which is negative of 1 by root 2, negative times 2. Okay, so we are going to get the same thing in negative. Negative 1.42. This one is negative 2. This one is negative 1.42. So these are the coordinates. Now we are good to go for drawing the graph. So this is the horizontal line, means here on this we'll drop all the points that we have written under x-axis. So since it is a video, you can just pause and later on see this data that I'm erasing so that I can draw a very beautiful graph if I get good space on this. So I'm erasing these, and those coordinates I'm going to put. I'll take some scale factor so that the graph appears. So that is the vertical line, y-axis information, point of intersection is this. Every 2 units on the horizontal line, I'll take a coordinate. So 0, then this one is a fourth, then the next one is 1 upon 2, the next one is 3 upon 4, then the next one is 1, the next one is 5 upon 4, next one is 7 upon 4, then whole number 2, and then the negative values that also comes in scale factor. Negative 1/4, negative 1 upon 2, negative 3 upon 4. Amplitude is 2, so I'm taking every 2 units as 1, so that's 1, 2. What numbers do you see on y-axis is 0, 2 and 1.42. 1.42 means what? This point is 1.5. 1.42 will be a little less than this. Here I'm drawing a line so that we understand that the graph amplitude will be up to this on either sides. So getting a line ready until that above as well as below. So that's negative 1 and that's negative 2. So 1.4 will be a little less than 1.5, negative 1, this one. So the graph will be in this zone, going up to this height above and below. Let's start plotting. So first one is the 0, 0. I'll be encircling those points. 1/4 and 4.2. 1/4 and 1.42. So this is the next point. Half and 2. So it rises. Oh yeah, it rises up to this. 3/4 and 1.42. So it comes back here. 1 and 0. Lovely. It is on the x-axis. 5/4 and negative. It is here. That's it. Then 3/4 and negative 2. 3 upon 2 and negative 2. So this is that point. Very beautiful graph is coming. 7 by 4 and negative 1.42. 7/4 and negative. Oh, yeah. It's traveling in this way. That is it. And 2 and 0. This completes one cycle. Though the other part also have taken the coordinates. So I'm taking that. This is that point. And negative half and negative 2, so it goes a little bit below that, and then it starts rising. Yeah. Now these points have to be connected with freehand, because between them, if you take some more angles, x-axis data, if you take some more, then you will get all the points, and ultimately you realize that they are not straight lines. In between, the points will come like curves. So sinusoidal graph is a curve. So you are supposed to connect them with freehand, because these are the end points. Between them, there are so many millions of points. So this graph of 2 sine pi x looks like this. I hope you liked it. This is literally such a beautiful graph. So it keeps on going. It's a wave, sinusoidal wave. It is like this. This is the graph of y is equal to 2 sine pi x. Sorry, 2 sine pi x. I hope this video is useful.